Okay, today we're going to start a new unit and we're going to look at polynomials. And today's lesson is going to be on classifying or naming polynomials, getting familiar with them. So a lot of this is going to be definitions. First, we're going to look at what is a monomial. Mono is a prefix you might recognize. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So what does that mean? Another name for a monomial would be a term. We also call them terms. So let's look to see what they are and what they are not. When you have 5 times x, multiplying is a product. So we have the product of a number and a variable. So that is a monomial or a term. In this example, we have a negative exponent. Remember, with negative exponents, to simplify them or get rid of them, we have to move them downstairs. If we were to do that, we would now have a division or a quotient. And remember, in the definition, it had to be only multiplication. So because of that, that is not a monomial. You cannot have a negative exponent. Negative 7 times x times y. That is a monomial. It is the product of a number and 2 variables. This next example is not, because you have a subtraction sign. 4x is a monomial and y is a monomial, but they are 2 monomials, which makes it actually a binomial. You can have a decimal. You still have a number with a positive exponent on a variable. This one is not, again, because you have a division bar, which is the quotient. So in summary, a monomial is a term where you have numbers and variables being multiplied together, and the variables have to have whole number exponents. We can find the degree of a monomial. Now I'm going to use the word monomial and the word term. Those are synonyms, so you'll hear me use them interchangeably. So a term and a monomial are the same thing. So when you look at this, we can find the degree of a monomial by adding the exponents of the variables. So if you look at the first monomial we have here, negative a, or negative 2a squared b to the 4th, we have 2 variables. With exponents, we add them together, and the degree of that monomial is 6. In the next example, we have 4, but we do not have a variable. Without a variable, we cannot have an exponent on the variable, so the degree would be 0. In the next example, we have the variable y with an exponent of 1, so the degree is 1. So all you do is you find the variables and add together the exponents on those variables. So a polynomial is a monomial or a sum or difference of monomials. So you can have a monomial or you can have monomials linked together with plus and minus signs, and that makes a polynomial. You can find the degree of the polynomial by finding the monomial with the highest degree. In this example, we have 2 terms, or 2 monomials. Let's find the degree of each. 4x has an exponent of 1, so the degree of that is 1. Negative 18x to the 5th power has a degree of 5, so the degree of the entire polynomial is the higher one, is simply 5. In the next example, we have 3 terms, or 3 monomials connected together with plus and minus signs. Let's find the degree of each. Here you have x squared and y to the 1st. That gives us a degree of 3. Here we have x to the 1st, y to the 1st. That gives us a degree of 2. This one has no variable, so degree of 0. So the entire polynomial has a degree of 3. It's the one with the highest degree. Another example. The degree of the first term is 4. The degree of the second term is 2. The degree of the third term is 1. And the fourth term is 0. So the degree of the entire polynomial is the highest one, which is 4. In the first term, we have a degree of 3. Second term, a degree of 2. Next term, a degree of 1, so the highest term is 3, so the degree of 3. Now these have all been written in standard notation, where each term is in order from highest degree to lowest degree. We have that example here too. X squared has a degree of 2. It has a degree of 1 because there's an exponent of 1 and 0, so the degree is 2. Here we have a degree of 4, 3, 2, and 1, so the degree of the entire polynomial is 4. Now these are not written in standard form, so you're going to write them in standard form and then find the degree of the entire polynomial. First of all, let's look here. This has a degree of 1. This has a degree of 3, degree of 0, degree of 2. If we were to write that in order from highest degree to lowest degree, we'd have the x cubed, then the x squared, then the x, then the constant. When you have it in standard form, you can easily find the degree of the entire polynomial by looking at the leading term. So this has a degree of 3. In this one, if we were to write it in standard form, we would write x to the 5th power first, x to the 3rd power next, x squared, and then the constant. So it would be x to the 5th plus 9x cubed minus 4x squared plus 16. And the degree of the entire polynomial is the highest degree, which is 5. Now on your notes, we're going to have special names for some of these. We're going to name or classify each polynomial based on its degree and on the number of terms. Looking at the degree, if you have just a number without a variable, we call it a constant. If you have a number with a variable with an invisible 1 as the exponent, if you were to have the equation y equals 4x plus 2 and you were to graph that, it would graph as a straight line. So we call this linear. So if you have the highest degree as 1, it is a linear equation. If the highest exponent is a 2 and you have this, we call it a quadratic equation. Those are going to graph like parabolas. We're going to look at that in the near future. If you think about degree of 3, can you think of a prefix that we use for 3? You can use tri, or you can use cube, and this is going to be cubic. We had quadratic. Now we have cubic with the degree of 3. If the highest degree is 4, if you think about a prefix for 4, we have quad and we have quar, like 4 quarters in a dollar, 4 quarts in a gallon. So this is going to be a quartic polynomial. If the highest degree is 5, if you think of a prefix that means 5, we have like a pentagon, a penta. But so we also have quin, and this is going to be quintic. Now, all of these polynomials have special names up to the degree of 5. When the degree gets to be 6 or more, we do not give them special names anymore. It's like you had more than 5 kids. You named the first 5 kids a name. And then when you got to the 6th kid, you say, oh, you're just kid 6, kid 7, kid 8. So if the degree is 6 or more, you're just going to say it's the 6th degree, or the 7th degree, or the 8th degree, and they do not have a special name. That is naming polynomials based on their degree. We are also going to name polynomials based on the number of terms. If you simply have 4x, that is one term. A prefix for 1 is mon, so we have monomial. If you have 2 terms, such as 4x plus 5, the terms are combined to link together with a plus or minus sign. You have 2, if you think of a prefix for 2, think of a bicycle with the prefix bi. So this is going to be a binomial. If you have 3 terms linked together with a plus or minus sign, 3 terms. If you think of a prefix for 3, we have like a tricycle. So we're going to call this a trinomial. Monomial is one term. Binomial is two terms. Trinomial is three terms. Now, again, when you get to be over three kids, over three, they do not have special names anymore, and we call every one of them a polynomial. So if it has 10 terms, we just call it a polynomial. If it has 6 terms, we call it a 6-term polynomial. Now, how does this all get put together? We're going to classify or name each polynomial according to its degree and the number of terms. So first, let's look at the degree of each term. The degree of this term is 2. The degree of this term is 1. The degree of this term is 0. So the highest degree is 2. So we look up here. The highest degree is 2, so we're going to call it a quadratic. We count the number of terms. There are 3. So it is a quadratic trinomial. In our next example, the first term has a degree of 0, 1. Here we add the exponents together. That's a degree of 4. Degree of 3. The highest degree was a 4. Since the highest degree was a 4, we call it a quartic. And there are 4 terms, so it is simply a quartic polynomial. In the next example, we have a degree of 2, and we have a degree of 3. The highest degree is 3, so we're going to call it a cubic, and it has 2 terms, so it is a cubic binomial. In our last example, we have 9m. The degree is 1, and it has only 1 term, so it is a linear monomial. So as you classify polynomials today, you're going to look at the degree, the highest degree of each term, name it by its highest degree, and by the number of terms, giving it 2 names. Something else we'll be doing today is you're going to be given some polynomials that are not simplified. Before you can classify them, you have to simplify them, which means you have to combine like terms. Like terms are terms that have the same variable with the same exponent attached. So in this example up here, you will see that we have 2 terms that have y squared. We call those like terms. So we would combine them together. We also, if you look at this polynomial, have 2 x terms. Those are like terms. We combine them together. When we combine the y squared terms, we get 3y squared. When we combine the x terms, we get a negative x squared. And then the y term and the constant come down, and now we have the polynomial simplified by combining the 2 like terms. These combined right here, these combined right here, and then we just brought this one down and this one down. That's a lot of lines drawn on a paper. Now that we have it simplified, we can name it based on its degree and number of terms. The highest degree is 2, so it's quadratic. It has 4 terms, so we classify it as a quadratic polynomial. On the back side of your paper, you're going to be looking at some equations, and you're going to be plugging in numbers and simplifying them. For example, the surface area of a cylinder is given by the polynomial. Here is the equation. You've probably called it equation before, but that is a polynomial. 2 pi radius squared plus 2 pi radius times height. A cylinder has a radius of 2 centimeters and a height of 5. Find the surface area. Notice they're giving you the numbers to plug in. Radius of 2, so your r is 2. Height of 5, so your h is 5. And they've given you the equation to plug it into. So you're just going to plug it in and solve. So it would be 2 times pi times radius, which was 2, squared. I'm just following the equation up here. Plus 2 times pi times the radius, which was 2, times the height, which is 5. So they've given you all the information up here. You're just plugging it in. Now, if you remember PEMDAS, we have a certain order of operations that we have to follow. But first, with each monomial or each term, you always evaluate the exponent first. So with my calculator, I would type in 2 squared. Then you can multiply it times pi you can use the pi button, or you can use 3.14 and then times 2. So order of operations, you would do 2 squared times 2 times pi. And you're going to get that answer on your calculator. You're going to add it to, over here, there's no exponents. So you're just adding 2 times pi times 2 times 5, and you're getting that number. Whoa, back up. I do not have a calculator handy with me right now, and I guess I don't have the answers up here. After you multiply and get those two numbers, the last step is to add them together. And then you'll find the answer. So it's just a matter of plugging in numbers and evaluating them using your order of operations or your PEMDAS. Good luck on your assignment today.